So today we are going to discuss on role of cache memory. I'll give you brief about cache memory. Right. So let's see. Just to cover what is cache memory and everything, but the entire introduction of cache memory that I give you will be used here in memory hierarchy. So we have some basic concept, cache memories, right? So whatever I'll be discussing here, it will be useful here as well. And cache memory do come in GATE exam, so you may want to learn it, right? Now about memory organization. So just giving you brief about how the memories are. First one is register. Why it is known as level 1? Because you know that as soon as the ALU generates any request, it takes up its data either from register or from main memory. If it is taking from main memory, it will generate the main memory request. Otherwise, it will directly fetch it from the register. Next, we have cache memory. Next, main memory, and at last secondary memory. Secondary memory can be your pen drives, your hard drives, flash drives, and your secondary memory is HDD or SDD, any secondary memory which is there, in which the data is presenting. How to fetch the data from secondary memory to main memory, that you will learn in operating system. So in operating system, you will have this primary memory, secondary memory. There will be a page table from which you'll be fetching the data from secondary memory. CPU will generate the virtual address. Virtual address means that virtual address page table will directly corresponding to secondary memory, and from there the data will fetch to main memory. In computer organization, we are simply more concentrated on register and main memory. Why we are only studying register and main memory? Because we are referring 8085, that's microcontroller or microprocessor. These days, it is more concentrated on how the main memory, cache and register is happening. Then how do you cover this cache memory? You will cover it in computer organization perspective of view. Like I'll give you the entire, and you will also study this cache memory in your operating system. So these are two different concepts. You have to grab both of them simultaneously. Here we'll just study the organization part, that how these are organized, and of course the data part, that how the data is traveling, everything is happening. So we'll study that as well. So about the size, these are very less in size. They generally consist of bits, bytes, right? They can hold that much memory, mostly 0 ones. Memory is data is stored in form of 0 and 1. These are larger than 16 kilobytes, and these are larger than 16 GB, although we have 4 GB RAM, 2 GB RAM, 8 GB RAM. But for good functionality, like if it is 16 GB, it is good. So you can perform some deep learning operations as well if it is more than it. Of course, it requires GPU. So your last topic is GPU. We see the organization of GPU as well. And then secondary memory is there. It could be in terabytes, it could be in GB, depending upon the data and usage that user wish to keep in. It depends upon the secondary memory. Next, implementation. So there are multi-ports, customized multi-ports. Multi-ports means, see, when we integrate the circuit, so we use different types of this ICs to integrate a circuit. In this, what we do, registers are pre-built. So for registers, multiple ports already to ALU is assigned. so that the data can be directly fetched from these registers. Cache memory is generally from like known as static RAM. This is dynamic RAM. Why it is static RAM? Because or why it is dynamic? Because whenever there will be execution request from the CPU, directly it will fetch from register or it will generate the request to main memory. That is why it is known as dynamic also. And it is made up of from capacitor, and this is generally because the size of cache memory is small, so it is generally made up of flip-flop, and these are magnetic tapes, drives. So yes, these are quite big memories, so they have certain sectors. Organization of hard disk you will study in operating system in your last chapter, that how the sectors are divided and everything, how to go into one another sector. This you will cover it in your operating system in large. Next, access time. Of course, if the memory is small, this is the smallest one, the access time will be the fastest. Whereas if you see the access time of secondary memory, of course it will be large, because first is it has to, CPU will generate the request, it has to see the virtual table. Virtual table will be exactly mapped to the secondary memory. It has to search in the secondary memory, get it to the virtual table, transfer to main memory, and then the data will be fetched by CPU. So this is a quite big process. That is why these are access time. Access time means when CPU is generating the request, how fast we can access it. So that is access time given in nanoseconds. Next, bandwidth. So of course, if we talk about the bandwidth, it will be the fastest. Although it consists of very low data, right? So depending upon the architecture, whether it is when main memory we talk about, uh, it is bit slower, and likewise it goes. And how it is managed by. So this one is managed by a compiler. When you compile, right, any code, it goes to the execution part. When it is going to the execution part, at that time, what happens, CPU or your ALU will generate the request, it will be fetched from there. Whereas cache memory is hardware, managed by hardware. That means hardware enable. You can just buy a cache memory. It could be of any size. Let's say if it is greater than it, and you just put that chip in the motherboard. So it is particularly hardware level it is managed, whereas registers are named in a micro programming or micro programming. When it is done at hardware level, at that time they are named and then managed by compiler. This is managed by operating system. So large part of it you see you manage through operating system. If it is like how it is managed means, suppose if there is a RAM of size 8 GB. So how much memory to allocate for which kind of program, it is usually done through operating system. And backed by, so whenever there is no data in the register, right, in the registers there is no data found, it will take it from cache memory. If no data in cache memory found, it will take it from main memory. If no data in main memory found, it will take it from secondary memory. If you do not have any data, so it may be from CDs, DVDs. These are like back days. Now you have pen drives, hard drives, flash drives, or maybe some cloud also. So depending upon it, you change the requirement. Now according to the hierarchy design, CPU or register generally have word, right? So they give they generate word request. Then cache memory is given in blocks. Main memory, this you will study in your operating system as well. Physical address space, PAS. Physical address is always generated or physical address, you can just keep it in your mind. If you are going for a gate exam, physical address space or PAS refer to main memory. Logical virtual address or logical virtual space is depicted by secondary memory. Who is teaching you operating system?
Uma Shankar sir.
Okay, great. So logical address is for secondary memory. Hit ratio equals 1 means what? See, if you are able to find, CPU has generated a request and it is able to find the request in register itself. We say hit ratio is 1 for register. If it is not found in register, then it will go and check for cache memory. So we say hit ratio of cache memory is 1. So not going any further. But in cache memory, you do not find everything. So hit ratio of main memory is 1, we say. But we do not find everything in main memory, then we say that hit ratio of secondary memory is 1. So sometimes in questions, you will find that you are provided with hit ratio. When they say the cache memory hit ratio is 1, you have to see that whatever blocks are there in cache memory is able to provide the data to the CPU or to the ALU. We mean hit ratio 1. If we say hit ratio of these two are 0, right? So by default, we mean that hit ratio of main memory will be 1, but sometimes it may not be. Then they will specify in the question, right? So depending upon the question, it will be targeted.
Ma'am, quick question. Main
Yes.
memory issues pages, right?
Main memory,
Issues pages, right?
no. Secondary memory issues pages
Okay.
and
May,
main memory issues block. So
okay.
yes. So what happens is, suppose if the data is not there here, so it has a like register. See, we have seen in the first class either it is word addressable or it is byte addressable, right?
Yes, ma'am.
The memory, yes. So if it is word addressable, we are supposing if it is word addressable, one word could be 16 bits or depending upon the architecture. So it will say that it is missing and I require these many words. Now cache memory is bit larger. So what happens? It consists of all the blocks, like blocks. So it will generate the block request. Now main memory has got pages. It has got pages, which is physical address space, and it will request to secondary memory. Secondary memory will give these requests in the pages. So these two share the pages, these two share the blocks, these two share the word, something like that. So it is generating word request. So word is consist of registers, but it is sharing the request. Yeah.
Registers consist of words, right? Then
Yes, yes.
okay. 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 Okay.
Yeah.
I think I understood. Register and cache share words. Okay, fine.
Yes, yes. Cache consists of block, main memory consists of pages. You may ask that what secondary memory consists of. Secondary memory do not consist of anything, it only consists of locations. How it is mapped then? Through virtual address space. Now what is virtual address space? This is also a page table. So page table is maintained by, these pages are maintained by main memory and secondary memory, for both page tables are maintained. So for that you have to study operating system. If not, like one day when we complete the syllabus and you wish to know, because I have notes for operating system as well, so you wish to know about how these pages are assigned and everything is happening, I can like tell you in one day. Yeah. So this is it. Now we go next. CPU generate memory request and it is initially referred as cache memory. All this, you can read that if a word, whatever I've explained you, word, so there is a miss and we have seen what you're talking about, word blocks. Secondary memory, if, Now, yes, okay, this also you can, yeah, this fourth point. According to hierarchy design, CPU perform read and write operation only on cache memory, which is reusable data space. So as I was telling you, the old architectures, when the cache was not present that efficiently, they used to target main memory. Now the for new operating system, they target cache memory. If in cache, if the request is not there, then it will go to main memory. So this property is named as locality of reference. So which locality of reference we refer? There are basically two locality of reference. One is temporal, one is spatial. Temporal means it refer to same word in the same block in near future. And spatial means CPU refer the adjacent word in the same block near future. So suppose if there is a table, in temporal what it will do, it will refer the same word in the same block. So if same word address is space is generated, it will look at the same block in near future, and then if it is not found in the same block, it will go to the next or generate the request if it is not found in the entire block.
Ma'am, please
Where
draw this, ma'am.
yes, yes,
Excuse me, ma'am.
yes, yes.
Ma'am, on a physical level, where exactly is the cache memory located? Like we know that the registers are located inside the CPU, then we know that the secondary memory is like physically
Yes, yes.
stored.
When
So,
you see the way you see your RAM, exactly like RAM is your cache memory. The only thing is it is made up of flip-flop and it is soldered very near to the IC of your microprocessor. So it is a very small memory. If you Google it, you can check that there is a, black color kind of memory which is soldered in the motherboard just near to the ALU. So if you see processor, you find good processors of like they are costly, but if you find i5 or something, it will be costing you 5 to 6,000 and it is this much size. So it is of course 3D this much size, and just beside it there is a cache memory.
okay,
Yes,
ma'am.
yeah. So when we see this, yeah. So 1 second. Here suppose we say so suppose this is your block of memory, yeah, and likewise you have one more. So first we understand the temporal difference. Suppose the CPU is referring the memory, cache memory. Now same word in the same block in near future. So suppose what happens, CPU has generated this request, this is same memory location, it will refer it. This is temporal, always with respect to time it will refer it. If it is not found, right, at same block, then what it will do, it will go find other blocks. If not, request is generated to main memory stating that you give me this uh, data and it will be fetched over here. This is temporal. Whereas in spatial, what it will do, suppose if it has generated, again CPU has generated the request and the data is found here, somewhere here. So what it will do, the data is found here. Next time it will generate the request, it will start from here itself. And then it will look at the adjacent blocks, right? If data is not there, it will fetch it from here, right? But if data is there, then it will not. So these are generally what we are talking about, page replacement algorithm strategies, and we'll be discussing all these once in near future when discussing about cache memory, right, in detail. But this is about temporal. Temporal means just going to the one word every time, same location. Whereas suppose in now there is no change here, but in this, suppose third here the data was, suppose it was checking here, and now the data is found somewhere here, right? Somewhere here the data is found. Next time it will go and check over here whether data is there and then go. So likewise the spatial locality means. Understood? At least say yes or no.
Yes, ma'am.
Okay, okay.
Understood.
Oh, great, great, great. So this is, you can read about it. And in the hierarchical memory design, low level memory data is subset of high level memory data. And this property is known as inclusion, means it consists of, it is including. So this is known as inclusion. High level and low level, you know, high level, when low level means maybe your register, and high level means maybe your secondary memory. So that is why it is subset, right? Next, you types of memory organization. So maybe this will study, yeah, the miss and everything. These will come to the when we study this cache memory, right? We stop here. So till date we have completed. Yeah, you go in basic concept, role of cache memory, pipeline performance, data hazard. So one is tutorial. If you have any doubt in tutorial, that means in very next class you can ask me with the list of doubts. Otherwise we go with the other ones. Because if we
Ma'am, the
quit,
tutorial, like where is the tutorial questions?
no, tutorial questions you want me to give, or you want me to give you the present, like you wish to present on these days, or you want any activities that to be done, like I give you the question and simultaneously we solve, how you wish to go about it.
Ma'am, you give the questions and we simultaneously solve, because I tried understanding microprogramming. I didn't understand like how to exactly go around solving it.
Okay, so what we'll do is tomorrow I give you some 20 minutes lecture on microprogramming and hardwired everything. We solve most of the questions from here. Tomorrow we'll solve. If we are not able to complete many questions, then in the next tutorial also we'll solve it, right?
Fine, ma'am.
Mom, when
So-
exactly will we be getting the notes?
Notes I'll be giving you because I myself is figuring out which to like which images to include where. So once I compile them, I'll share it with you.
Okay.